Everyone, welcome to another lecture in fluid mechanics and hydraulic machines. So myself Dr. Padala Rajshekhar, Assistant Professor, Department of Civil Engineering and School of Engineering, SR University, Warangal, India. And we'll see the recap of the previous lecture, then we'll go with the other thing. And we have discussed about hydrostatics deals with the fluids at rest and the forces that are exerted on surface. And we have seen the total pressure as well as center of pressure and for a horizontal surface. And for a vertical surface, and pressure increases with depth and the center of pressure lies below the centroid. Now we will see one kind of problem. A rectangular plane surface is 2 meters wide and 3 meters deep. You see here it is 3 meters wide and it is 2 meters wide and 3 meters depth. It lies in vertical lane in water and determine the total pressure and position of center of pressure on the plane surface. When its upper edge is horizontal, and you see here the upper edge is horizontal and A coincides with the surface and B 2.5 meters below the free surface of the body. And you can see B is equal to 2 meters, D is equal to 3 meters, and given the first condition coincides, so as we know force equal to rho G A H bar, where rho is equal to 1000 kg per meter cube and A is equal to 3 into 2, that is 6, and H bar is equal to 1 by 2 into 3, that is 1.5 meters. Total force is equal to 88,290 newtons. So depth of center of pressure H star is equal to Ig by A H bar plus H bar. Ig is nothing but BD cube by 12, B into D cube by 12, 2 into 3 cube by 12, that is 4.5 meter per 4. So this is 4.5 and you can see here H bar is 1.5, here 1.5, here 1.5, area is 2 into 3, 6. So total you will get 2 meters H star. H star is nothing but center of pressure. And case B, with respect to 2.5 meters below the free surface, upper edge. And F is equal to rho G A H bar, as usually rho is equal to 1000 kg per meter cube. A is equal to 3.2, 3 into 2, and F is equal to 1000 into 1000 into 9.81 into 6 into 4. So it is 235,440 newtons. So depth of center of pressure H star is equal to Ig into Ig by A into H bar plus H bar. Ig is equal to BD cube by 12, that is 4.5 meter per 4. That is nothing but just substitute 4.5 by 6 into 4 plus 4. So 4 you will get by H bar and 4.5 you will get by Ig. That is equal to 4.1875 meters. We'll see one more thing. problem, hydrostatic problems, determine the total pressure on a circular plate. Just now we have seen rectangle. Now we are going with circular. Of diameter 1.5 meters. So here it is 1.5 meters, and which is placed vertically in water in such a way that the center of pressure of the plate is 3 meters below the free surface of water. Find the position of center of pressure. That means here we have to find H star. Already they have given H bar. So imagine there is a dam and there is a water we are storing, and this is a kind of circular gate opening instead of rectangle. So there will be a center of pressure and center of gravity and center of pressure. Center of pressure always it will be acts middle, and below that some force you can see with respect to pressure, like with respect to below the thing, center of pressure. Now we are going to calculate. Given d is equal to 1.5 meter, h bar is directly they have given, no need to calculate 3 meters, and here we have to find two things, total pressure and position of center of pressure h star. So solution, area of the plate is equal to pi by 4 d square, that is equal to pi by 4 into 1.5 square, that is 1.767 meter square. So total pressure equal to rho g a into h bar 1000 into 9.81 into area 1.767 into 3. Then you will get total pressure in terms of 52,002.81 newtons. Position of the center of pressure, that is equal to H star equal to Ig by A into H bar plus H bar. Already we have found H bar, here you can see that is 3 meters, and area just now we have calculated, that is 1.767, and we need to know Ig. So this is the only term where we have to find. Ig is nothing but pi by 4, pi by 64, d power 4. What is pi? 3.14, and 64 we know, and d power 4 is nothing but diameter, that is 1.5 power 4, and 0.2485 meter per 4. Hence H star equal to 0.2485 by 1.767 into 3 plus 3, that is equal to H bar, that is nothing but 3.0468. 3.0468. Okay, because it is more than h bar. So that's what. Now you see, determine the total pressure. Determine the total pressure on a circular plate of diameter 1.5 meter, which is placed vertically. Which is placed vertically in water in such a way that the center of plate is 3 meters below the free surface of water, and find the position of center of pressure. That's what they have given, and that means h star we have to find. H bar already we have. So diameter of the plate D is equal to 1.5 meters and h bar equal to 3 meters, and the area is equal to pi by 4 d square, that is pi by 4 d means 1.5 square, and force is rho g a into h bar, that is 1000 into 9.81 into 1.767 into 3. And coming to the position of the center, h star is equal to ig by a into a into h bar plus h bar. So already we know ig from pi by 64 into d power 4, and area is 1.767 and h bar is equal to 3. Now first initially we have seen a kind of thing called a rectangle. Next we went slowly with circular. Now we have to go with triangle. An isosceles triangle plate of base 3 meters and altitude is 3 meters. So base is 3 meters and depth is 3 meters. Is immersed vertically in an oil specific gravity of 0.8. The base of the plate coincides with the free surface of oil. Determine total pressure on the plate and center of pressure. So both ways we have to calculate. One is total pressure on the plate and second one is center of pressure. These both things are required. So once you see, then we will start solving. Now area mention half BH. So everyone knows triangle area is half BH. 3 into 3, half into 3 into 3. That is 4.5 meters square. And specific gravity is 0.8. And center of gravity h x bar is 1 by 3 into h, 1 by 3 into 3. And total pressure on the plate P is equal to W into A into x bar. That is equal to 0.8 into 9.81. That is into 4.5 into 1. That is equal to 0.8 we know, 9.81 we know. and 4.5 area already we have calculated, and one is x bar that we got from here, that is the distance of the center of gravity from the free surface, and p is equal to 35.3 kilonewtons. For total pressure we have calculated. Next, center of pressure. Center of pressure is given by the relation h bar into Ig into A into x bar plus x bar. So BH cube by 36, and A is already we calculated, x bar already we have calculated, that is 1. So we know x bar is 1 1, and A is already we have calculated, that is 4.5, and B we know, B or H is both are same here. So BH cube means 3 into 3 cube by 36. H bar is equal to 1.5 meters. H bar is equal to 1.5 meters. Here itself you can see it is having exactly center. X bar is 1. So 1 means greater than 1. So once again we'll see. An isosceles triangle plate of the base 3 meters and altitude 3 meters is immersed vertically in an oil specific gravity 0.8. The base of the plate coincides with the free surface of oil. Determine total pressure on the plate and center of pressure. So area is equal to half into BH. So half into 3 into 3, that is 4.5 meters square, and S is equal to 0.8. So x bar is nothing but the distance of CG from the free surface of oil. X bar is equal to 1 by 3 into H, that is 1 by 3 into 3. That is 1 meter. We know that P is equal to WA into x bar, that is 0.8 into 9.81 into 4.5 into 1, that is 35.3 kilonewtons. And center of pressure is nothing but Ig, that is equal to 3 into BH cube, 3 into 3 cube by 36 by 4.5 into 1 plus 1. So finally H bar is equal to 1.5 meters. This is a class assignment where you people need to do. Determine the total pressure on a circular plate. Already we have discussed of diameter 2 meters, which is placed vertically in water in such a way that the center of plate is 4 meters below the free surface of water. Find the position of center of pressure. So here inclined plane surface. Now we have seen horizontal, next vertical. Now we will see some kind of inclined plane surfaces. When a flat surface is placed under a liquid and tilted, not horizontally or vertically, because both cases we have seen, and it is called an inclined surface. That means you see the total pressure is equal to F is equal to rho GA into H bar, and center of pressure is equal to H star is equal to Ig into sine square theta by A into H bar plus H bar. So the total pressure on such a surface is still due to the weight of a liquid. But unlike a horizontal surface, every point on the surface is a different depth. So the pressure varies from point to point. That means you see the calculations. H bar equal to H plus D by 2 into sine theta. You see, it is in a position of inclined position, and we cannot calculate directly H bar and H star. So H bar means it is with respect to center of gravity. H star is with respect to pressure where force is applied, and this is the depth and this is the width. So in that way we have to take cross dimension with respect to straight. Then we will understand, but with respect to some kind of theta. So now we'll see one problem that you people will understand. Inclined plane surface equal to like a 1 meter wide and 1.5 meters depth. 1 meter wide and 1.5 meters depth rectangle plane surface lies in water in such a way that its plane makes an angle of 30 degrees. So as I mentioned, there will be 30 degrees with the free surface water surface. Determine the total pressure. Determine the total pressure and the position of center of pressure when the upper edge is 0.75 meters below the free water surface. Now you look at the figure H bar and H star. H bar we know 0.75 where H is equal to 1 meter. Now we see H is equal to 1 meter and theta is equal to 30 degrees. That is equal to, this is 0.75, this is 30. So we will get another one like 0.75 into 30 degrees. That is equal to H bar is equal to 1 plus already 1 meter depth plus 0.75 into sine theta, sine 30 degrees. So once observed properly, then we will go for problem. Inclined plane surface, total pressure P, we know that P is equal to rho GA into H bar. So area is equal to 1.5 into 1, that is 1.5 meter square. And depth of the centroid 0.75 they have given plus 1.5, that is the depth, by 2 into 0.5. Then you will get 1.125, and computing the total pressure 9.81 into 1.5 into 1.125, that is 16.55 kilonewtons. Coming to the center of pressure, H bar equal to Ig into sine square theta by A into x bar plus x bar, where Ig equal to 1 into 1.5 power 3 by 12, that is equal to 0.281 meter per 4. H bar equal to 0.281 into 0.5 square by 1.5 into 1.125 plus 1.125, that is x bar. This is area, this is Ig 0.821, and this is sine square theta, such that we'll get the value as 1.166 meters. Now we'll see another one problem. A circular plate 1.5 meters diameter is submerged in water with a greater and least depth below the surface being 2 meters and 0.75 meters respectively. Determine the total pressure on one face of the plate and the position of the surface center of pressure. Here they have given diameter as 1.5 meters and H1 is 0.75 and this is D2 as we know, and H2 is 2 meters. So H1 is like here 1.5 diameter and theta, then you will get sin theta is equal to 1.25, which came from 2 minus 0.75. H2, H1, that is 1.25 by 1.5, that is 0.83. H bar is equal to 0.75 plus d by 2 into sin theta, that is equal to 1.375. And total pressure, that is equal to force, is equal to rho g A into H bar. So center of pressure H star equal to Ig into sin square theta by A into H bar plus H bar. Given diameter is 1.5 meters, H1 is 0.75 meters, H2 is 2 meters. So finding total pressure and position of center of pressure. Solution: diameter of the plate 1.5 meters and area A pi by 4 d square. Pi by 4 into 1.52, that is equal to 1.767, that is square. 1.767 meters square, and total pressure we know that WA into X bar 9.81 into 1.767 into 1.375, that is 23.83 kilonewtons. And on center of pressure H bar, using the relation H bar equal to Ig into sin square theta by A into X bar plus X bar, that is equal to pi by 64 into d power 4, which we have discussed earlier, into 0.8 double like 83 whole power square by 1.767 into 1.376 plus 1.376, that is 1.446, that is H bar equal to 1.446. Now we can see one more thing, curved surface. When a curved surface like a pipe or the side of a cylinder is submerged in a fluid, then each tiny strip of the surface is at different depth. So each feels like a different pressure. Also, each strip is tilted in a different directions. So the force from the pressure acts in a different directions at each point. So here water surface equal to this one diagram with respect to some cos theta sin theta formulas. So here we have considered a strip. You see here diagram A, B, C, and here we can see curved one. You can see this is a curved one. That is equal to dF is equal to P rho into A, that is equal to P into area, P rho GH into dA, that is integration of rho GH into dA. So here we can see the total pressure with respect to x component is F d into Fx, y component d into Fi. Total pressure is equal to root of Fx square plus Fi square, that is equal to position tan phi is equal to Fi by Fx. So shall we have one problem? So a shutter in a dam is having a quadrant shape of radius 2 meters, and find the resultant force due to water per meter length of the gate. Find also the angle at which the total force will act. So this is the thing A and B and Fy Fx. Now you see, given radius of the gate is 2 meters and width of the gate is 1 meter, and we need resultant force and angle of acting force. Let Fx is a horizontal force acting on the projected surface of the curved portion. Force equal to force on OB refers to rho GA H bar. Here A is 2 into 1 where we can see here that is 2 meters. H bar is half into 2 that is 1 meters. And f of x is nothing but 1000 into 9.81 into 2 into 1 that is 19620 newtons. The similar way vertical forces weight of water supported by AB that is imagined and rho into area is nothing but of OAB into unit width. So this is 1000 into 9.81 into pi by 4 2 square into 1 that is 30803.4 newtons. Resultant force equal to Fx square Fy square. So 19620 whole square plus 30803.4 whole square that is equal to 36534.4 newtons. So tan theta is equal to Fx by Fy that is 1.57 and theta is equal to 57.505 that is 57 degrees 37 minutes. Now you can see one more concept called buoyancy force. A lemon will sink in fresh water but floats in salt water. That's you people, if you need you can try. If you are having a fresh water, then the lemon will sink. If you are adding a salt, it will float. Now see, imagine like a fresh water is having density 1 gram per centimeter cube and lemon is having 1.2. If you are adding salt water, then the density of water will increase to 1.3 to 1.05. So the behavior of the water, lemon sinks here. Lemon sinks in fresh water, but lemon floats in salt water. That's what we can see. This is salt water. As you can see, this is salt water. This is normal water. Here you can observe. That means same water, same lemon. But why it is floating? Because just adding the salt in that, the ability of that increases in the density, so floating conditions will happen. The lemon is denser than fresh water, so it sinks, and next salt water is denser than the lemon, so the lemon floats due to the beyond force. So fresh water is less dense, then the lemon will sink, so it cannot support it. So that way buoyancy force is nothing but it is lifting because the weight is coming down, so it will lift. So next class we will see about in depth about buoyancy force. Then you people will understand easily. So just try it. Take a glass of water and try with lemon. Definitely it will sink. And another glass of water. Just try with respect to salt. Adding salt water and try lemon. Then it will float. So that's what a lemon will sink in fresh water but floats in salt water. Okay, then thank you.